Hello, welcome back. In this video, I'm going to be going over 3 ACT math questions. For all these problems, I recommend pausing the video and trying all the problems yourself first before you see me solve them. Without wasting any time, let's get into it. Question 25 says, for the right triangle shown below with the given dimensions in inches, which of the following trigonometric expressions has a value of 4/5? So for this problem, what I would do first is I would figure out BC, because if we look at our answer choices, right? If we want to find the value of sine A, we're gonna need to use the side BC. It's gonna be the opposite, right? Opposite over hypotenuse. That's how you find sine of A. The opposite side in this case is BC, and we might need it for the other answer choices as well. So let's find out what BC is. So to solve for BC, we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. A is 9 in this case, b squared is BC, which is what we're solving for, and c, our hypotenuse, 15. If I solve for b, I get subtract 81, b squared equals 144, take the square root. So b equals 12, which means BC also equals 12, right? So the thing to realize here first is that, so the question's asking us which of the following trigonometric expressions has a value of 4/5, right? We don't have 4 or 5 as one of our side lengths in this triangle, but 4/5 is the same thing as 12/15, right? So we're looking for a trigonometric expression in these answer choices that gives us a value of 12/15, which is the same thing as 4/5. And that is actually going to be sine of A, because sine of A is the opposite side from angle A, which is 12, over the hypotenuse, which is 15. And this is the same thing as 4/5, right? So that means the answer to this question is A. On to question 43, which says the circle below has a diameter of 8 centimeters. Which of the following is closest to the area in square centimeters of the square inscribed in the circle? So for this question, you need to realize that the diameter of the circle is also equal to the diagonal. I'll draw out our square. Okay, that's our square, and let's put in the diagonal, right, which is 8. Remember, all sides in a square are equal, so let's just call the side x, side lengths x, right? And the square can be broken down into two equal triangles, two equal right triangles. And we need to solve for x, right? So then we can figure out the area by taking the side length and squaring it. That's how you figure out the area of a square. So let's do that. This is your triangle. You have x, and we have 8, right? Let's just use the Pythagorean theorem to solve for x. You can also use the 45, 45, 90 triangle to solve this as well, but let's just use a Pythagorean theorem for this. So it's going to be x squared plus x squared equals 8 squared, and if we solve for x, it's going to be 2x squared equals 64 divided by 2, x squared equals 32. If we take the square root, it's going to be x equals square root of 32. This is our side length of the square. And to find the area of a square, it's the side length squared. So it's going to be root 32, our side length, and we're going to square that. So it's going to be 32, and that's our area of the square. On to the last question, question 48, which says that given that x and 7 minus x over 2 are integers, which of the following statements about x must be true? So for this problem, first let's review what an integer is. an integer is a whole number that does not have a fractional or decimal part, right? It could be positive, like 1, 2, 3. Negative, like -1, -2, -3, or 0, right? So these are integers. So now it says that given that x and 7 minus x over 2 are integers, which of the following statements about x must be true? So the thing to realize here is that let's specifically look at 7 minus x over 2, right? If we plug in, let's say, 0 for x, right? 7 over 2, that's 3.5. That has a decimal, and that is not what an integer is, so this wouldn't work. If I plug in, let's say, 2, okay? 7 minus 2 is 5. 5 over 2, that's 2.5. Again, same thing. This has a decimal, and we're looking for an integer. A decimal is not an integer, right? So it's not this either. The pattern to notice here is that whenever the numerator is odd, we're going to get a decimal, which means we want 7 minus x, we want that to be even, right? And how do we do that? Well, let's see. If I plug in 1, I get 6. 6 over 2, that's 3. So that's an integer, right? 7, if I plug in, let's say, 3 for x. 7 minus 3, that's 4. 4 over 2, that's 2. That's also an integer. So the thing to notice is that whenever x is odd, 1, 3, 5, right? Then you're going to get an integer. So that means x has to be odd, which matches F. I hope my explanations made sense, and thank you for watching.